Now, beyond just calculating residuals, then we need to look at the influence, because there's kind of the fundamental question. We know that cases with big residuals will have that influence on the outcomes. But let's actually look at the influence that they're having. I mean, it's instead of just kind of esoterically. How do you measure, is this case having a big influence on the results? So we can kind of see here, again, it can pull, an outlier can pull it, or it may not. There's various ways to look at the effect that a case can have on the regression coefficients. Right? Well, actually, kind of look here. See here, notice this outlier, it's changing the intercept. Notice the intercept, with the outlier, the intercept's going higher. And with the outlier, the slope is getting flatter. So the slope is going down, but the intercept is going up. Both regression coefficients are changing. So again, there's various ways we can detect the influence that each case has on the regression coefficients. One thing is called leverage. And leverage is what's called a global measure of influence. Kind of some characteristics. It's larger the further away you are from mean, just like we were just talking about. The leverage that a case has will be bigger the further away it is from the average of the x's. The maximum score for leverage can be as 1. It has a mean of k plus 1 over n, so however many variables you have plus 1 divided by n is the average. And people will typically then look at anything double that. If Kavanaugh's leverage is double or triple that number, it may warrant a closer look at your score, at your data. But the thing to keep in mind, even though we talk about leverage as an influence, it's not actual influence. It's potential influence. Leverage only reflects x. It doesn't take into consideration what actually happened on y. It's looking at how far out are you on the x's, which means you can. And it's kind of like a seesaw. I think that's where the leverage comes from. You can think of it as a seesaw. It has the potential to really change the results. But even if you've got a high leverage value, it doesn't mean that you did. It just means you might have. And it's a way of flagging cases that could be having a disproportionate influence on the results. It's telling you that you got a few people that are really kind of hanging out there. And you may want to take a look at the data and see, is there a problem or is there a reason why they're way out there? As a result, you can have variables with the same leverage that could have, because it's not taking into consideration what the outcome is, there could be two variables out here with a really big leverage. And one of them is messing up the regression coefficient, and the other's not, because it's like right in the middle of where everything should be. So again, leverage is just potential influence. What's kind of interesting with leverage, this is how, in simple regression, this is the formula for calculating leverage, which is what we just saw, right? We just saw this with the studentized residuals. Same with the, well, actually, again, here's the formula, the studentized residuals. It's just that hat matrix thing. It's that little, it's that variable, well, you can think of what HII is, what the hat matrix, well, the diagonal of the hat matrix. What leverage is telling us again is kind of how is it related. Yeah. It's telling us how much leverage the case could have. Let's just leave it at that. Another measure of influence is what's called Cook's distance. And so you will see people talk about leverage. You will see people talk about Cook's distance, particularly if they get to, well, we excluded cases because their Cook's distance was greater than. You might read someone doing that. It's another global measure of influence. So it's not telling you which regression coefficients are getting messed up, but it's telling you that a variable that a case is having an influence. it is influencing, it does look at, because it's got the residual in it, it looks at the influence based on both X and Y in this case. So Cook's distance is looking at real impact on the regression model versus the potential impact that it might be having. Unfortunately, there's like no real criteria. How do you know something's big or not? But you could look at a range of, you look at Cook's distance for all of your cases, not all the variables, all of the cases. And again, if a couple stand out, it tells you that those cases are having more of an impact on the regression coefficients, on the regression model. You can kind of think of, in a way, this combines all of the, right, instead of, it's not looking at each of the individual regression coefficients, it's kind of looking at all of them and saying, how are you having an influence on the overall model, kind of on the gestalt of the regression analysis. DFBETA, which I personally like, is a little different in that it's now looking at each individual regression coefficient, which is why some people don't like DFBETAs. And what happens to each regression coefficient as each person is deleted from the analysis? So if you've got, if you got 100 subjects, you perform, well, the computer does it for you. It performs 100 multiple regressions, and for each regression, it says, okay, I'm dropping Kavanaugh, and I'm going to look at the regression, what happens to the regression coefficients for each regression coefficient when I drop Kavanaugh, and that's going to be the DFBETA. For the intercept, how much did the intercept change? So it looks at the original intercept, and then the intercept when we've dropped Kavanaugh. And that's that DFBETA for the intercept. And then for X1, it does the same thing. It looks at how every regression coefficient changes when Kavanaugh is dropped from the analysis. And then it does it for Chapin. And it does it for Toby, and on and on and on. Okay. The trick is, so you can, well, one of the problems is that's an awful lot of numbers. It's kind of, in that sense, there's a balance between Cook's distance, which gives you one number for every person. It kind of summarizes all those DFBETAs. So, you may want to kind of go back and forth between the two. If you've got a big Cook's distance, can you, on a record, are there specific regression coefficients that seem to be in play for that person? Or is it just kind of across the board? There's no criteria because you're looking at differences in the standardized coefficients. How big it is, just looking at that number is hard to evaluate. There's no kind of, how do you determine something's influential? So you can actually standardize the DFBETAs, and these are pretty standard output you can request, is the DFBETA and the standardized DFBETA. And that just takes sure it divides each of those individual DFBETAs by the standard error that you'd estimate for that coefficient for that person. So now you've basically converted them into, theoretically, they're not standard scores, but they're more standardized, but they're not Z-scores. We should be clear on that. The criteria, it's still very squishy. You'll see some say that the anything with a standardized DFBETA above 2 should be looked at. Some will say 1. I think you see this number a lot, 2 over the square root of n for small samples, which can tell you, for small samples, if your sample's really big, they're all going to be bigger than that. But it's kind of hard to, it's really something you need to look at the totality of across all the data. What sort of pattern do you see in these? And not just get into dropping cases willy-nilly. Talking about dropping cases